Welcome to the final day of Hierarchy of Quadrilaterals. A quick review about what we've gone over thus far. Remembering a quadrilateral is a four-sided polygon, 1, 2, 3, 4 sides with the sum of the interior angles totaling to 360 degrees. We moved on to the trapezoid, where we had one pair of parallel sides. More specific type of trapezoid, the isosceles trapezoid. Isosceles meaning that these two legs are congruent, and thus those two base angles are congruent. In addition, the diagonals spanning across the trapezoid are congruent, and again that was found by SAS. The adjacent angles not along the same base, so these two angles and these two angles are supplementary, and we took note that that mid-segment of the trapezoid spanning across here is equal to the top plus the bottom divided by 2. Top plus bottom divided by 2. Then we got into the parallelograms. Parallelograms have two pairs of sides, and these sides are both congruent and parallel to each other. In addition, the opposite angles are congruent, so those two and these two, and all adjacent angles are sup, right? Sup, 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 sup. Diagonals bisect each other, meaning that going from an angle to the center is the same distance from both angles that are opposite of each other. Moving into a more specific parallelogram, we have the rhombi. Rhombi difference, all the sides are congruent. The opposite sides are still parallel, but they're all congruent. The diagonals bisect the opposite angles, so if you look across, these two parts are going to be equal, these two parts, and all four of these are actually equal. And these diagonals are actually perpendicular bisectors, because remembering back here, right in the middle, right, the diagonals bisected each other. Now they're perpendicular bisectors, so they form right angles. So therefore, you'll have 4 right triangles in the rhombi. Alright, then we looked at another type of parallelogram, the rectangle. Big difference between a parallelogram and a rectangle. Rectangle, all the angles, they're all right? So 90 degrees for all 4 angles. And the two diagonals are congruent to length. So that means this length is equal to this length, is equal to this length, is equal to this length, forming 4 different isosceles triangles. The square was our final one, and the square is super picky because it must be both a rhombus and a rectangle. So it's got every property we've listed, and the diagonals are going to form 4 congruent right triangles. So all 4 of these triangles are congruent. Today we're going to go up into the sky with our lovely kite. Our kite is our last quadrilateral we need to go through, and the special thing about the kite is that we have 2 pairs of adjacent congruent sides. So our first property, there are 2 pairs of adjacent congruent sides. So looking at this picture, we have this side would be congruent to that side, they're adjacent, and this side would be congruent to this side. In addition to sides, we also have our angles, and in a kite, only one set of opposite angles are congruent. So, one set of opposite angles are congruent. And for this one, we'll look at this angle being congruent to this one. The reason why we can't always say that these two are going to be congruent is because these two side lengths are different. So if we made 2 triangles, we're going to have very different angle measures. And in addition, we also know kites can be drawn something like this. If we had that, this angle would be congruent to this angle. This side would be congruent to this side. This side would be congruent to this side. But are those 2 angles congruent? This one and this one? No, they are not. So we cannot say that both opposite angles are congruent. Looking at our diagonals, alright, let's take a second and draw in our diagonals spanning across our kite. Okay. Now, our diagonals, as you see where they intersect, forms this lovely right angle. So our diags are perpendicular to each other. Right? Basically just saying that where they meet forms a right angle. That's a right angle, that's a right angle, right angle, right angle. And our fourth and our final property, our diagonals bisect opposite angles. Meaning that this diagonal is going to form these two congruent parts. It's splitting that angle. It's going to split this angle in half. Again, not necessarily the same angle as the one across from it, but those will be equal. And then these, let's make them like that with a little T on it, are all going to be congruent, because if it's bisecting, those are congruent, you know the whole angle's congruent, so each parts will be congruent. And if you look, it looks like we have a triangle here that'll be congruent to a triangle here, both right triangles, and the triangle on top congruent to the other triangle on top. Again, both right triangles. So you should be able to figure out side lengths, and you should be able to figure out angle measures. And that is our hierarchy. So congratulations, you made it to the end, and we will now put all this project together and get a final product.